goes up the grade, what are the forces acting on it? Now, when the car is moving up the grade, what is the direction of the frictional force? The frictional force will be down the grade. So, the forces acting on it are mg sine theta, that is the component of the weight pulling it down, and the force of static friction, which will be mu s mg cos theta. I hope you are now familiar with these. The frictional force, the force of static friction will be mu s mg cos theta. So when the car is moving up the grade, the forces that opposes motion is mg sine theta, that is pulling the car down, and the frictional force that is opposing the motion. Now, these two forces are the net force on the car, which produces the acceleration. We can therefore find the acceleration, which will be a negative acceleration. And once you have the acceleration, we can find the time taken by the car to stop in a certain distance. Is that right? Okay. Now, when the car is going down the grade, what are the forces now on the car? The difference is, when the car is going down the grade, mg sine theta is always down the grade. But when the car is moving down, the frictional force will now be up the plane. So, when the car is now moving down, mg sine theta is down the grade. Mu k mg cos theta, which is the frictional force, will be acting up the plane. And the net force therefore will be, the frictional force minus mg sine theta. It is that net force that stops the car. Well, here we assume that the frictional force is greater. Otherwise, the car will never come to a stop. Is that right? And therefore, in the case when the car is moving up the grade, the net force trying to stop the car, or the net force that produces the negative acceleration on the car, is mg sine theta plus mu k mg cos theta. And when the car is going down the grade, the net force producing the acceleration on it is mu k mg cos theta minus mg sine theta. Alright, let's now write that down. So what are we looking for in this problem? We are looking for the minimum distance it takes to stop the car while it is going up the grade, and the minimum distance it takes to stop the car while it is going down the grade. Okay, now here is the road and the car is going up the grade. Theta equal to 15 degrees. V0, the car is going at 30 meters per second when its engine just goes off. Is that right? We are not using the brakes. We are using the force of friction. Now, we need to bring the velocity to 0. With an initial velocity 30 meters per second, we need to bring the final velocity to 0. And you know mu s equal to 0.7. Those are the data that we know. So the car is going up the plane. Is that right? I want to run the car one more time. The car is going up the plane. You need to know how far will it go. What is the distance it will go up the plane before it stops. When it is here, its speed is 30 meters per second. And you know what are the forces acting on it. So the weight mg of the car is acting vertically down. That's the usual routine that we do. mg sine 15 degrees will pull the car down the plane. So what is the force pulling the car down the plane? mg sine 15 degrees, that will be, we don't know the mass of the car, but g sine 15 degrees is 2.54. So The force that is pulling the car down the plane is 2.54 m, where m is the mass of the car. Alright, so this is 2.54 m. Okay, and mg cos theta is the normal force, and that will be equal to Fn. When the car goes up the grade, when the car is going up the grade, what is the direction of the frictional force we said? It is down the grade. And what is that frictional force? Fs equal to mu s mg cos theta. Now, mu s is known, we know that is 0.7, and so multiply 0.7 with g cos 15 degrees, and that will give you 6.6. So watch here again, the 6.6 is this mu s, which is 0.7 times 9.8 times cos 15. Now please check that on your own. 0.7 times 9.8 times cos 15 degrees is 6.6. That means Fs is 6.6 m. We don't know the mass of the car, so we leave it as such. The frictional force Fs is 6.6 m. And what is the direction of that frictional force? It is down the grade because the car is going up. So Fs equal to mu s mg cos theta, which is equal to 6.6 m. Alright, now what minimum distance does it take to stop the car? We need to find the acceleration of the car using the net force. The net force on the car is the sum of these two forces. The total force pulling the car down the plane, trying to stop it, is 2.54 m plus 6.6 m. That will be 9.14 m. And this net force will produce a downward acceleration of negative a. The acceleration is negative because it is opposite to the direction of motion. So that net force equal to ma. You see that? The net force on the car is 9.14 m. That net force produces an acceleration negative a on the car. Negative acceleration, downward acceleration, such that 9.14 m equal to negative ma. Now we don't need the mass of the car, it cancels from both sides. And that gives you directly a equal to negative 1.14 meter per second squared. That is the acceleration of the car downward. And now we can use these values. V0 equal to 30 meter per second. The final velocity V has to be 0. The acceleration is negative 9.14 meter per second squared. The question is, what is the distance the car will travel before coming to a stop under these conditions? Tell me, what is the equation we are going to use? We know the initial velocity, we know the final velocity, we know the acceleration, we need to find the displacement. What is the equation that is connecting all these quantities? Well, if d is the distance the car moves up so that the velocity becomes 0, then v squared equal to v0 squared plus 2ad. Well, normally we call it v squared or vf squared equal to v0 squared plus 2ax if the motion is in the x direction, or 2ay if it is in the y direction. Since the direction of motion is not x or y, we simply call that distance d. So v squared equal to v0 squared plus 2ad. Well, we know all these values. V will be 0. V0 is 30 meter per second. Acceleration we just calculated as negative 9.14 meter per second squared. Therefore, we can solve for d. So, 0 equal to 30 squared plus 2 times negative 9.14 d, and solving for d gives you d equal to 49.2 meter. The car will come to a stop at a distance of 49.2 meter. Okay, let's now do the B part. What is the B part? If the car is now rolling down the grade, it has an initial velocity 30 meter per second, final velocity will be 0. What is the distance the car will roll down before it stops? That is what we need to find. Well, when the car moves down the grade, the force mg sine theta will be acting down the grade, and mg sine theta is 2.54 m, the same value that we calculated earlier. But the force of static friction now will be opposing the motion, and we calculated that again in the previous slide, that is 6.63 m. So that's the difference now. The car is moving down. The V0 is 30 meter per second down. The force of friction opposing the motion is 6.63 m, which is mu s mg cos theta. So the net force on the car now is mg sine theta minus mu s mg cos theta. And what is that equal to? 2.54 m minus 6.63 m. mg sine theta we calculated earlier is 2.54 m. Mu s mg cos theta is 6.63 m. And that will be, how much is it? And that is negative 4.1 m. The net force on the car is opposite to the direction of motion, and that is the reason why it is going to come to a stop. And this net force is going to produce an acceleration on the car of mass m. F net equal to ma. We can now calculate the acceleration. So F net negative 4.1 m equal to ma, and m will cancel, giving us the acceleration is negative 4.1 meter per second squared. And to find the distance it travels before it stops, we can use the same equation. What's the equation? If d is the distance the car moves down the plane so that v becomes 0, then v squared equal to v0 squared plus 2ad. And again, v will be 0, v0 is 30, a, the acceleration is negative 4.1 meter per second squared, and using those values, we can now calculate d, and d equal to 109.8 meter. Okay, I hope you are comfortable with the arguments that we are using in solving these problems. Well, I'm going to stop now. We have done enough number of problems in force of friction, and there is one more lesson in this unit before you are ready for your test 2. I hope you are doing your homeworks regularly. You see, the only way to learn a course like this well is to do all the assigned homework, and make sure that you do them and get back to me if you need any explanations. Alright, I'll see you for next lesson. That will be on circular motion. I will see you for that shortly.